Now guys, we can look about column vectors. So here you can come and say that in a coordinate plane, the vector representing a shift from one point to another is written as a form. Now, a vector A and vector B can be written in column form as AB. Now this, in this case, that AB, now this is our column. Now we can call column vector, where A and B are in the changes of x and y direction. And now we can come that A and B is in changes of y and x direction. We can come and say the modulus of the modulus of this vector, that is AB, is equals to square root of A squared plus B squared. Now in units. Now let's look example. Point A 2 3, B is 5 7, and C is negative 3 15. Now here we are told to find AB. AB and AC. Now we have first to write A in column vector 2 3, and B in column vector is 5 7, and C in column vector is negative 3 and 15. Now here we are told to find AB. Now, so in this case AB is equals to, now it is, now here AB implies that this is negative. We are minusing, or we are subtracting A, that is B, from A from B, that is. Now in our case A is 2 3 and B is 5 7. Now this it will be 5 7. Now this minus 2 minus 3, which it is 3 4. Now this is our, which it is our AB. Now we can come and find AC is equals to, our AC we are given as negative 15 and 15, negative 3 and 15, and our C we are given, no, our A we are given as 2 over 3, which it is negative 5 negative 5 12. This is our AC. Now we are still told to find the modulus of AB. Modulus of AB. Now modulus of AB, which is denoted by this symbol, is equals to AB square root of 3 squared plus 4 squared, which it is 9 plus 16, and this is square root, so is equals to square root of 25. So modulus of AB is equals to 5 units. Also, we are told to find the modulus of AC. Modulus of AC is equals to square root of negative 5 squared plus 12 squared is equals to square root of 25 plus 1 44, which it is equal to square root of 169. So our modulus, and this is modulus, is equals to 13 units. Now we want to continue the same way. Now let's consider A is equals to 7 4 and B is equals to 5 1. So we are told to maybe we are told to find, let's say, a plus b and 2a plus maybe 3b. Now for the a plus b, now here we come and find it will be 7 4. Now here the reason why we did not add here, it is because we are told to find AB. Find AB. Now this implies, now this is AB. Now this is dot product. But in our case, we are told to find A plus B. Now here we are going to add direct 5 1, which it is this 7 plus 5 and 4 plus 1, which is 12 5. Now that is our AB. We are also told to find A 2A plus 3b, which is this. Now it is 2 multiplied by 7 4, which it is a, plus 3 multiplied by 5 1, which is equals to, now this is 14 8 plus 15 3, which is equals to, now 14 plus 15 and 8 plus 3, which is equals to 29, and this is 11. Now we can say that we have found our a plus b and our 2a plus 3b. In our case, we have gotten this. All right. Now this is a plus b, and now 29 over 11. Now we are correct. Now let's say we are told to find a minus b, and in this case is our modulus. So now we need first to find a minus b. In our case, a minus b, it is 7 4 minus 5 1. This implies 7 minus 5 and 4 minus 1, which it is 7 2 3. But we are told to find modulus. A minus b is equals to square root of 2 squared plus 3 squared is equals to 4 plus 9, and square root it is. Now here it is square root of 13. Since this is not, cannot be subdivided, okay, cannot be simplified further, we gonna leave it like that. Now we come to another subtopic called parallel vectors. Parallel vectors. Okay, we can say that a vector a and b, that is, let's consider a vector a and vector b. Now for these two vectors to be called parallel, there must exist, or we can say it is they are called parallel if a is equal to kb, where k is a real number. K is a real number, i.e. maybe 1 2 3 up to n. Example, let's look an example. An example, we can say determine, or let's say we are given a set of vectors a as 2 4 and b as 3 6. We can say that determine the pairs which of the following pairs are of vectors are parallel. Determine which are parallel. Now here we can work out using, now we want to find, now we can see that, now in this case, okay, we can see that b, okay, now here we have to find that if you can divide this by, okay, a, okay, we can say b is equals to What can we multiply this by 8? Now we can say it is 3. So 3 over 2 times 2 is equals to 3. And we can come and say 3 over 2 times 6 is equals to, by that one, by that. It's 3. Okay, 3 over 2. Okay, this is 4. By that one, by that 2 is 6. Now we can come and say that B is equals to 3 over 2. A. Therefore, A is parallel to B. Now here we come to find numbers. Now in this case, our K is equals to 3 over 2. Since B is equals to KA, then it is parallel. Okay, we can find for another, we can get another one here. We can say that E is equals to 4, 2. Now we can call this as 2. We can say that E is equals to 4, 2, and F is equals to negative 2, negative 1. Now here we want to find such that F is equals to K E. Now you need to find the value of K. Now we can come there and say that negative 2, negative 1 is equals to K into 4, 2. We can come and say negative 2, negative 1 is equals to 4K over 2K. Is it? Okay, we can come and say that, should we cross multiply? So we can come and say it is, if we cross multiply this and this will be 4, 4. Okay, now it will be equals to 2 over 4, which it is by this one, by this one. So we can come and say, we can come and conclude that F is equals to a half, and it is negative E. Therefore, therefore, we can come and conclude that E is parallel to F. Now we have seen parallel vectors. Let's consider A and B. They are called parallel. Now these are vectors. If A is equals to K, B, where K is real number, that is, it can be 1, 2, 3, or even fractions, 1 over 2, 1 over 3, or negative 1 over 8, any as long as it's a real number. And we have seen how we can solve all this. Also, we have seen how we can solve column vectors. We have seen how to find modulus here, and so forth. So we can look about midpoint theorem.